In this presentation, we'll see finders algorithm with example and few short questions. The aim of this is to implement and demonstrate the finders algorithm to output a description of the set of all hypotheses which are consistent with the training examples. So basically, this is a concept learning algorithm in the machine learning. That is, it finds most specific hypothesis that fits all the positive examples. Out of two cases, positive and negative examples, the finders algorithm will find out only the positive cases, find out specific hypotheses which are suitable for the positive examples. For the purpose of demonstration, we will take a popular example, that is enjoy sport, having 6 different attributes like sky, air temperature, humidity, wind, water, and forecast. The result can be yes or no. If at all any question mark if you see, that means it is too general. It accept any values. These attributes accept single value, like temperature can be warm or cold. Any one value is accepted. 0 indicates that no value is accepted. These are the 6 attributes: sky temperature, the values what it takes, sunny, cloudy, or rainy. The temperature could be warm or cold, humidity could be normal or high, wind could be strong or weak, water could be warm or cold, forecast same or change. The target function C can be written x, which is either negative or it could be positive, 0 or 1, yes or no, like that. Hypothesis is described by a conjunction of all these constraints on the attributes. These are all the attributes, these are the constraints. So this gives you hypothesis. Set of all this is a training example which consists positive or negative. So hypothesis H in H is such that H of x equal to C of x, where C of x is a constant. H is a hypothesis for all D. This is the data set what we are going to use, having 4 entries. In that, 3 are positive example and 1 is a negative example. If some instance x satisfies all the constraints of hypothesis H, then H classifies as positive. It is written like H of x equal to 1. H of x, the hypothesis H of x equal to 1. So this constraint has to be satisfied. Sky should be sunny, or temperature should be warm, humidity should be normal, wind should be strong, and so on. There are 2 cases that will come here. One is the most general cases which accept any value. Other one is a specific hypothesis which accept pi or null or 0 value. These are the 2 cases. We are moving from specific hypothesis to general case or general to the specific case. The algorithm works like this. First, you initialize with the most specific hypothesis. That is all zeros. That number of 0 depends on the number of attributes. You have to consider only the positive examples. For each positive training instance X for each attribute constraint AI in X. If the constraint AI in X is satisfied by X, then do not do anything. Otherwise, you have to replace it by a question mark. So you repeat it for all the cases. Can be represented for chart in this way. Initialize, identify the positive examples, check for attributes. If attribute value is equal to hypothesis value, do nothing. Otherwise, replace that value with the question mark. We'll take the example one by one. The first step is to initialize. The first step is to initialize the hypothesis with a pi or 0. Now, this is our first training example. Observe whether it is a positive example or negative example. This is a positive example. It is clear that hypothesis is too specific. This is too specific, but we have the value. So none of the constraint in it are satisfied by this example. So we have to replace it to this thing. That is, H1 now becomes sunny, warm, normal, strong, and safe. There are 6 attributes. These are the values changed from most specific to that little general cases. We'll go for the second example. Second example, after observing the result, it is a positive example. We have to see. Sky, there is no change in the attribute, and air temperature also there is no change, but humidity there is a change from normal to high. That means it accepts another value also. Wind and water forecast, all these three remain same. So this H2 is written wherever there is a change in parameter, you have to replace it by question mark. Otherwise, same parameter, that is same attribute. So sunny, that is same because there is no change, and air temperature is also same. Normal is change, humidity is changed from normal to high. There is a change, so question mark. There is no change here. In these three parameters also there is no change. Keep those attributes same. Attributes. Wind is strong. Water is warm. Forecast is same. So this is H2. And the third example. The third example is negative case. So you should not do any modification to this hypothesis. H2 remains same for third example because it is negative example. The fourth example is positive example. We have to see. Again, sky remains same. So H3 or H4 can be written as H3 equal to H2, H4 equal to the first parameter, there is no change, and the second parameter is also same, warm. Third parameter, don't care. Fourth parameter, there is no change, strong. See, the parameter change from warm to cool. So replace it by question mark. And in the last parameter also there is a change from same to change. So replace it by question mark. This is the final attribute. The final hypothesis consists of sunny, warm, question mark, strong, question mark, and question mark. So this is applicable for all positive cases. The first parameter should be sunny, second attribute should be warm, and the third parameter Fifth parameter, sixth parameter can take any value. That is the meaning of this question mark. Fourth parameter point should be strong. Then only swimming can be done. Enjoy sport results, positive cases. Can be done the concept map. These are the different instances. Instances can be positive instance or the negative instance. We have got x1, x2, x4 are the positive instances. X3 is the negative instance. Most specific case, that is we start from 0, 0, 0, 0 like that, and most general case, here we don't have that all the question marks. So X1 is one such, that is sunny, warm, normal, strong, warm, and same. So that is little general, not too specific or not more specific. So X1 is mapped to this one. This H1 is mapped to the first instance, that is X1. Next, H2, that is sunny, warm, question mark, strong, warm, same, is mapped to X2. X3, as it's a negative example, you cannot map. The last case, H3, H2 are same. Last case, sunny, warm, question mark, strong, question mark, is mapped to X4. I'll give a little hint on this example. Take one more example. Having three parameters, the result could be yes or no. Initially, H is initialized to most specific case. So we should have three zeros, three pi. That is for three parameters. That is for size, for color, for shape. Observe the example. First example is positive example. So changing from most specific to general case. First parameter size is same, small, color is red, and shape is circle. This is after seeing the first positive example. In the second case, it is a negative example. H remains same. H2 equal to H1. Third is again positive example. You have to see is any change in the attribute or not. Size same. So H3 is size attribute is same. That is small. And color change from red to blue. That's a change. So it accepts red as well as the blue. So replace it by question mark. Circle same. So there is no change in parameter. That is for X3. X4. In this example, this is a negative example. So no change in hypothesis. H4 equal to H3. It considers only positive example. Similarly, the last one is also negative example. No change in hypothesis. That is H5 equal to H4. This is the final answer. One more example, the data related to the car manufacturing. It has got five attributes: origin, manufacturer, color, decade, the type. The example could be yes or no, positive, negative, like that. So initialize H not, that is pi, I, 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 and pi one more. So these five parameters are instilled to null 0, 5. First example is positive example. So H1 is equal to Japan, Honda, blue, 1980, and economy. H2 remains same because second is the negative example. H2 equal to H1. Third is positive example. You have to see the changes. So Japan same, Honda change to Toyota, blue same, 1980 to 1990, and economy same. So this is question mark. This has to be replaced by question mark. That is, Japan is same, Honda change to Toyota, blue is same, and year is changed, economy is same. This is the result after seeing the third example. Fourth example is negative. So H4 equal to H3. Fifth example is positive. H5 hypothesis to be modified if there is a change. Again, Japan is same. This you have to ignore. Blue is changed to white. This you have to replace by question mark. This already we have ignored. And the last parameter is same. That means Japan is same. Second parameter no change, that is question mark, it can accept any value. Third is color is not blue, need not be blue, it is white also. So question mark. Here already changed, economy. H6 is also a positive example. Check out any change in parameter. So Japan remains same. This is question mark. This is also question mark. This is also question mark, and the last is same. That is Japan question mark, question mark, question mark, and economy. See here it is same. So H5 is equal to H6. The last is negative example. So H7 which is equal to H6. So this is the final hypothesis which is consistent, which is same, which is applicable for all these positive examples. The first parameter should be, first attribute should be Japan, and type should be economy, and other three parameters can take anything. So it holds good for all the positive example. This hypothesis, final hypothesis, holds good for all the things. So the concept is learned from these examples. One more example you can take these three positive example. Initialize H naught equal to 0, 0, 0, 0, 0. H1 equal to the round triangle, round purple hair S. In the second example, in the third example, the second case, which is negative, so no change in hypothesis. Fourth example is, this third example is positive. H3 equal to C. Any attribute is changing or not. Round to square, so replace it by question mark. Triangle remains same. Round is also same. Purple is changed from yellow, so question mark. S is same. This is the hypothesis after third example. Fourth example remains same because it is a negative example. Fifth example is the positive. We see any parameters changed or not. So first is already question mark. No need to check it. Triangle, that second parameter knows type need not be triangle, can be square also. So it accepts these two values of question mark head should be round, same. The color is already changed, so question mark. Here is yes. No more examples points. So this is the final hypothesis, which is applicable for all the positive examples. This is to understand whether seed is poisonous or not based on four parameters, that is color, toughness, fungus, and appearance. So there are five positive examples and one negative example. So initialized H naught to all four zeros. The first example is positive example. The parameters are green, hard, no, wrinkled. Second is negative example. Third is negative examples. If there is no change in hypothesis, H3 equal to H1 or H2 equal to H1. So we have considered three examples. Fourth is positive example. Green is changed to orange, so replaced by question mark. Hard change to soft, question mark. No remains same. Wrinkle is also same. This is the hypothesis after third exam, after fourth exam. Fifth example is positive example. Already question mark came in the first question mark only. So second is also question mark, and in this case it is yes, no change to yes. So it can accept no as well as yes. So question mark. The last is wrinkle is changed to smooth. So question mark. So already we got all the parameters are most general. So no need to go further. So it will not change hypothesis. That means what we can say, these attributes can take any values, most general case. How the program can be written? See, first is to create this in CSV. You have to open that in, you have to make entries in the Excel file, save that as CSV. So import CSV. In this example, number of attributes are 6. 1, 2, 3, 4, 5, 6 attributes are required. Seventh attribute is positive or negative. So bring the data, load the data, use empty list, open CSV file, read the CSV file. This is the data in the object. Navigate to the last row, get the data, append it to list. Get the data, append it to list, repeat it till the last row. Hypothesis should be initialized to 0. How many zeros required? Depends on the number of attributes. Print initial hypothesis. If the first row is label, start from second row. Second row to initialize initial hypothesis. Okay. So you have to put that into the first. If your CSV file contains labels, so you don't want this first parameter, first row, second row honors data starts, copy that into the list. From there you pick the data, put it to hypothesis for all the attributes. 0 to the last attributes. From the second row, that is index value 1, copy that to hypothesis. As already, I assume that the first row is label row, second already copied. So you can start from to just to save the time. Check the last attribute. Seventh or index value 6 if it is yes, then only you have to modify hypothesis, otherwise no need. Navigate to all the attributes starting from the first attribute to the last. If they are not same, Attribute in the hypothesis and attribute in that just now read data are not same. Replace it by question mark. Otherwise, retain it. Replace or retain. Like that, you repeat for all the opposite examples. At the end, display. This is the program for find this algorithm.